All right, let's talk about trig ratios in another context. We're going to approach them in a different way. So let's say I've got a triangle, and I'm just picking a right triangle, I guess, but it doesn't really matter. So, and this triangle is twice as tall as it is wide. Okay? So say, for example, this one is, I don't know, I'm just going to pick some numbers out of a hat, 8 units tall and 4 units wide. Right? I could make it bigger. Say I have down here, say I make it 6 units wide. Well, I know that it's twice as tall as it is wide, so it's going to be 12 units tall. And over here, say I shrink it down, and I just make it 1 unit wide. Well, I know it's going to be 2 units tall because it's twice as tall as it is wide. In fact, there's like a whole family of triangles that are all twice as tall as they are wide. Or right triangles specifically that we're interested in here. So a whole family of right triangles that are twice as tall as they are wide. And what's more, that family of triangles, they all have something in common, is that they all have the same angles. Because that's true of all similar figures, including triangles. Right? If two shapes are similar, then they have all the same interior angles. So the angles in this triangle are the same as the angles in this triangle, are the same as the angles in this triangle. All the same angles. In fact, if I were to have any triangle at all, right? Any triangle at all, and I knew it had the same angles as this family, then I automatically know that it's twice as tall as it is wide. Okay? So, and this is where our trigonometry comes in. In a right triangle, if I know this angle right here, because I know that the right triangle has a right angle in it, if I know this angle, I automatically know that angle. Okay? So, in a right triangle, if I knew, say, what the relationship was between the base and the height, and I knew what this angle was, right? If I knew what the angle was, I knew what the relationship was between the base and the height of that triangle, I would know what the relationship was between the base and the height of any triangle at all that had that angle in it. And that's our key, because you do know that. There's a function in your calculator called tangent, and it tells you what the relationship is between the base and the height for any triangle that has any given angle between 0 and 90. Now, hold on for a second. In fact, for a triangle that has that angle, whatever it is, your calculator also knows the relationship between the height and the hypotenuse, or the base and the hypotenuse, right? So the one problem is that, like, if I were to turn this triangle on its side, the base and the height will get swapped out. So if I were to ask the calculator, for this angle right here, because the calculator will base everything on this angle right here, but if I turn the triangle around, it wouldn't know which way my triangle is sitting. So instead of like calling it base and height, the calculator has some different names for them. Right? They are called opposite, because that's the side that is opposite the angle. And then down here, adjacent. Adjacent means next to, and this is the side that's next to the angle, right? So now, instead of saying base and height, now if I turn the triangle on its side, well, if I turn it like this, the base of the triangle is now still opposite the angle, right? And the height of the triangle is adjacent the angle. So opposite and adjacent don't change when I turn the triangle around. So the calculator will always give you good information. All right, so let's take a look, for example. And I think in this first Khan Academy exercise, all they're asking us to do is identify what our trig ratios are. So we're not solving any problems really yet. We're just identifying what our trig ratios are. And they are sine, cosine, and tangent. And sine is opposite over hypotenuse. So it's the relationship between the side opposite the angle and the hypotenuse. And cosine is adjacent over hypotenuse. So cosine tells us what the relationship is between the length of the adjacent side and the hypotenuse. And tangent finally is opposite over adjacent. Opposite over adjacent, which tells us the relationship between the side opposite and the side adjacent. So again, if I know what this angle is, right, I can punch into the calculator, and the calculator will tell me what the relationship is between either these two, right, opposite and hypotenuse, or adjacent and hypotenuse, or opposite and adjacent. And then it's like knowing that the triangle is twice as tall as it is wide. So if I know either its height or its width, and I know what that relationship is, I can figure out the other side. In fact, I could figure out all three sides, using some combination of these. So again, sine tells us opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And again, opposite is the side that we have to travel to get across. We go across the triangle to get the side opposite. Adjacent is the side that's right next to the angle. Of course, the hypotenuse is also right next to the angle, but hypotenuse is hypotenuse. That doesn't change. Okay? And again, if we know the angle, then we know the other angle over here automatically. And if we know the angle and we know the other angle, we know what family of triangles it belongs to, and we know the relationships between the three sides. Of course, the calculator will give us those actual numbers, those actual values, and we'll deal with that later on. Right now, we're just trying to identify what's sine, what's cosine, what's tangent. So next, we'll take a look at some examples.